Hello, this is Untitled Chapter and welcome to SD Lessons. Today my subject is mathematics and the topic is mensuration. Let's learn and make the concept of perimeter, area and volume absolutely clear. Look here, I've drawn one leaf. And if you want to find out the perimeter of the leaf, then what do? There is no formula. You need to take one bending wire, place it on top of this, of the outer edge, stretch it long, use a ruler, measure it. Suppose if it is 30 centimeter, the perimeter of the leaf is 30 centimeter. Now, let's see how to find out the area of the leaf. I have made use of a graph paper. You place it on top of that, trace the leaf, count the number of squares, say if it is 50, and count the number of squares which are more than half. Say it is 10, then 50 plus 10, 60 square units. So 60 square units. Another very important thing as we proceed to the other formula, very important thing is to know the value of pi. Greek letter pi, pronunciation pi, 3.14159 non-terminating, approx 22/7. But how did the Greeks get this value of pi? Look at these three figures. Here are three circles of three different size. Circumference, C1 is the circumference, D1 is the diameter. Circumference divided by diameter, you get this value, 3.141 and so on. See the second one, circumference of a bigger circle, diameter also proportionally it increases. You divide, you get the same value. Third circle, you see this one, C3 divided by the diameter, you get the same value. And this value, constant value, is called pi. It is used in many important calculations connected with sphere, cylinder, cone and circle. Look at this one, area of a circle. What is the area of a circle? Pi, that value, r, you get the radius, square, r into r. Now the next one, cube. Cube, 1 square is L square, L into L. If it is 1 centimeter by 1 centimeter, it is 1 square centimeter. But how many sides are there all total? 6 are there. Look at this, I have opened the cube. You get there are 6 squares. So what will be the total surface area of this cube? 6L square. I'll show you another model. This is a cuboid. This is not a cube. This is a cuboid. Now here length into breadth. You find this one. Here I have length, I have used 4. Breadth is 3. 4 3s are 12. But how many sides are this? One here, one here. L into B, 2LB. Now let's see this one, L into H. One this side, one this side. So 2LH. Then B into H. One this one, B into H, and one this side. If I open this, you get the total surface area of a cuboid. And what do you get the formula? 2 outside the bracket, because you get 2 this one and this one, 2LB, 2LH and 2BH. So what is the final formula? 2 within bracket LB plus LH plus BH. I haven't mentioned it here. So that is how we get the formula of total surface area of a cuboid. But I will be explaining you how to get the total surface area of a cylinder. Look at this cylinder. This has been cut open. If you cut it open, you get a rectangle like this, and this one, it comes here and here. If you calculate, one circle is pi r square, two circles is 2 pi r square. I have written 2 pi r square, this one and this one. And what about this one? This length is the circumference of this one, that is 2 pi r. And what about this height? H. So 2 pi r into h gives you the area of this one is here. Now 2 pi r square and 2 pi r h. 2 pi r is common, r plus h. That is the total surface area of a cylinder. But if you are asked to give only the curved surface area, then is this one only 2 pi r h. That means you don't get the lid, you don't get the base. That is not the total. That is curved surface area. Let's have the concept of volume. Here's a small cube. How many such cubes will fit inside this one? A cylinder. Let's see all these figures here. How many such cubes will fit inside that? That gives you the concept of volume. Volume, how you do? Here, if you find out the cross-sectional area of the top, the red, colored it red. If you get the area of the top, multiply by this height or thickness, you get the volume of this. So, here you get L square is the top, height is also L, you get L cube. Volume of this is L cube. What about this one, cuboid? The top red part of the cross-sectional area is L into B, that is the cross-sectional area into the height H. So, you get LBH. What about this one? No formula. You have to get the cross-sectional area using a graph paper. Suppose this is a tree trunk. It has been cut in this way, tree trunk. Now, here, find the cross-sectional area with the help of the graph, multiply by the thickness or the length, you get the volume of this. What about the star, this one, this shape? You get the cross-sectional area of the star, multiply by the height. What about the cylinder? Pi r square is the cross-sectional area into h, pi r square h. What about the cone? Same thing, but it is 1/3 times of this cylinder. So, 1/3 pi r square h. But what about a sphere? Sphere volume, it is, just imagine the diameter. Suppose cut the ball into two halves. Then the diameter here, it will be pi r square cross-sectional area. Multiply by the thickness as the take as the radius, you get pi r cube. But one more thing you have to remember, 4/3 of that, 4/3 pi r cube. That gives you the volume of a sphere. There are a lot of formula, we will learn it in our next lesson. You keep watching, liking and sharing. Thank you and goodbye.